Okay, so in this video we would be talking about pressure. So let us begin. Pressure. Pressure is defined as force acting normally on a unit surface area. What does the word normally mean? Normally means acting at right angle or perpendicularly or at 90 degree to a surface. So mathematically, pressure is defined as force divided by area on which it is acting. Pressure is the physical impact of force. So in nature, the impact of force is measured as pressure. Okay, so this is the mathematical formula for pressure. Pressure is basically force divided by area. So pressure is a scalar quantity and its units are Newton per meter square or Pascal. Okay, so pressure exerted by fluids. So fluids are the substances that can flow. Liquids and gases form a part of fluids. So fluids also exert pressure on the walls and the base of the container in which they are kept. The magnitude of this pressure depends upon the height of the fluid present above the given surface area. So there is a simple formula which tells us about the pressure exerted by fluids, and that is pressure is equal to H rho g, where H is the height of the water or any fluid and rho is the density of the fluid and g is the acceleration due to gravity. Fluids exert pressure on the base of the container on which they are kept. For example, the base of the container is this part. So we could easily find out the pressure which a fluid exerts on this surface area by the formula H rho g, where H is the height, which is the height of the fluid present above that surface area. So above this surface area, this amount of or this height of fluid is present, so that height would be that, and rho would be the density of the fluid and g would be the acceleration due to gravity. Another example is this activity. In this activity, we are proving that the pressure is also exerted on the walls of the container. As we have seen that pressure is always exerted at the base of the container, but apart from the base of the container, the pressure is also exerted on the walls of the container, which are basically these two walls. So let us talk about that. So you can see the depth of this part is very less. So let us give this name D1. This depth, the depth of the second part is slightly more, and the depth of the third part is very much. So we could see the pressure at point 1 is very less, and pressure at point 2 is more, and pressure at point 3 is the maximum. So we could conclude that pressure increases with depth, and that could also be seen from the range of the water. The range of the water flowing from this point is the least. The range of the water flowing from this point would be slightly more, and the range of the water flowing from the last or the deepest point would be maximum because of the maximum pressure exerted at the deepest point. Okay, so let us move forward and read about atmospheric pressure. So atmospheric pressure is also known as air pressure or barometric pressure, and it is the pressure exerted by the weight of the air above a given location. This pressure varies with altitude, temperature and other factors, but it is typically around 101.3 kilopascals at the sea level. So atmospheric pressure is measured by a mercury barometer. So let us understand the working of this mercury barometer. So the pressure exerted by this column of mercury would be balanced out by the pressure of the atmosphere, which is the atmospheric pressure. So we could write that atmospheric pressure or PATM would be equal to the pressure of mercury, and we all know how to calculate the pressure of fluids, which was given by the formula H rho g. So by putting all the values of height, density and acceleration due to gravity, the pressure of atmosphere at any point can be calculated. At the sea level, this height comes to be 29.92 inches or 76 centimeters. So this is how you could calculate the atmospheric pressure with the help of a mercury barometer. So this was all. Thank you.